The most important factory in the world is being built in the middle of a desert with no water, no workers, and honestly, no roadmap. Everything you rely on, your smartphone, your car, even America's most powerful weapons, depends on the chips this place will produce. It's a $65 billion gamble. If it works, it could become a lifeline for the tech world. If it fails, the consequences could ripple across every corner of modern life. And that's why this story matters, more than you think. Right now, Taiwan makes 92% of the world's most advanced semiconductors. If that production stops, through natural disaster or geopolitical causes, the modern world stops with it. These chips allow the F-35 Lightning II to become a flying computer. It can identify enemy radar signatures, jam incoming missiles, and share data with ground troops in real time. Each chip is designed for a specific architecture and to a level of precision only a handful of machines on Earth can achieve. The chips allow missiles and drones to process GPS data and adjust their flight paths in real time. In modern conflict, the side that can process data the fastest wins. If Taiwan's fabs falter, America's most advanced weapons become vulnerable. And the stakes are existential. The United States military could be crippled, data centers that run military AI would fail, but the economic stakes are even more terrifying. A total disruption of Taiwanese chip manufacturing would trigger a global economic collapse. And, honestly, calling the crisis a recession is an understatement. It could easily be a hole in the global GDP that totals roughly $10 trillion in 1 year. That's about 10% of global GDP, equivalent to the economies of Japan and Germany disappearing overnight. The United States realized it had essentially outsourced its national security to a place it could not fully protect. The move to Asia made sense. It was cheaper. It was efficient. It was profitable. But, efficiency has a hidden cost. It's actually the enemy of resilience. The just-in-time manufacturing model created a world where no one has a backup plan. Now, Arizona is the backup plan. The United States handed TSMC $6.6 billion in federal grants. They found a patch of desert and asked one of the most sophisticated manufacturing operations on Earth to rebuild itself from scratch, in a place that has none of the conditions that made it possible in Taiwan. Is this real tech independence? Or just a multi-billion-dollar experiment that will never work? To the average person, a semiconductor factory looks like any other massive industrial site, just a cluster of giant windowless boxes. But inside, workers carve patterns onto silicon, a process that takes literally hundreds of steps with lasers and plasma in a total vacuum. One speck of dust ruins a batch worth millions. In the middle of the Sonoran Desert, where dust storms are just a seasonal reality, TSMC has to create an environment that is 1,000 times cleaner than a hospital operating room. The air is filtered hundreds of times per hour. The factories float on massive shock absorbers to stop vibrations from nearby roads. This control is what allows TSMC to build the chips for Nvidia and Apple. But honestly, the machines are only half the story. Taiwan's decades-old ecosystem can't be packed in a shipping container. Moving it to the Arizona desert instantly creates friction, with every part, person, and process facing new obstacles across the Pacific. TSMC's edge comes down to one thing: extreme ultraviolet lithography, or EUV. The laser inside each machine, well, it has to hit its moving target tens of thousands of times every single second. Any misstep, and honestly, millions of dollars worth of silicon, is ruined. Replicating this atomic-level perfection in the Arizona desert, day after day, is what makes this factory a gamble unlike any other. The human element adds more stress. Taiwanese culture relies on 12-hour shifts and fast changes. American workers, though, value a different balance between work and life. In Taiwan, an engineer might live in a dormitory right next to the fab, ready to wake up at 3 in the morning to fix a lithography error. In Arizona, that same engineer is probably sipping coffee 20 minutes away, wondering if waking up early counts as overtime in the United States. If you can't replicate how people work, you can't replicate what they build. Yet the first chips are finally coming off the line. TSMC is transplanting an entire civilization of knowledge into the sand. This tests whether the United States can rebuild a supply chain it lost decades ago. Arizona is the front line for the survival of Western technology. The project is not just building a factory, it's trying to clone an entire ecosystem in a place where it doesn't naturally exist. You're trying to grow an industry in the wrong soil. If TSMC Arizona succeeds, it proves that the most advanced tech in the world is portable. If it fails, it proves that the United States is permanently dependent on a small island in the most dangerous waterway on the planet. That's the question. Is this independence or I and Dengsen dance on Bor den Chur or Daner ba dan Krni Sakada D Dane Alda Dinosaur Jetzer I Danger Bur dan Veffer Andri Albeda Dane Store dan Our Daysten Bor very expensive experiment. The plan looks perfect on paper, but a single resource could bring the entire operation to its knees. Semiconductor plants are unbelievably thirsty, and they don't use normal water. They require something far more extreme, water stripped of every single mineral. TSMC's first Arizona plant alone needs over 4.75 million gallons of this specialized water every single day, just to rinse chips and cool down heavy equipment. The Colorado River is hitting historic lows, and the government is already cutting Arizona's supply. Building the world's most advanced tech in a dry wasteland is a geographic paradox. Phoenix is a city of 5 million people, already struggling to find enough water to survive. Now, it has a factory next door that drinks it like it's happy hour. In a standard factory, water is a utility. At TSMC, it is a chemical reagent. This water is so pure it becomes aggressive, pulling atoms out of anything it touches. If a single microscopic particle of calcium or magnesium touches a silicon wafer during the rinsing process, the entire batch is useless. To get there, TSMC has to strip water down beyond anything found in nature, removing every possible impurity. To create the chips, the silicon must be washed hundreds of times. 1 second of imperfection, and the yield plummets. In a business where margins are thin and the cost of entry is enormous, a yield drop is a death sentence. If the water levels drop too low, the factory shuts down. That simple event would stop production for everything from NVIDIA AI chips to military missiles. Arizona offered a huge, undisturbed land and the red carpet with fast approvals. To survive, TSMC is betting on a high-tech transition, a massive recycling plant that tries to save 90% of every drop they use. But water isn't the only thing this monster consumes. A chip factory is a black hole for electricity. The machines run 24/7. To etch the circuits onto silicon, they need massive, steady bursts of power. Arizona's grid is already under heavy pressure from the blistering heat. The state is adding solar panels as fast as possible, but is it enough? At the heart of this incessant hunger for power is the EUV lithography machine. Each one consumes about 1 megawatt of electricity. TSMC Arizona plans to house dozens of them. Each machine demands a cooling system capable of supporting a skyscraper. Multiply that by dozens, and the factory dictates the energy policy of the state. To keep the lights on, the state is building billion-dollar batteries and special power plants just for the factory. This creates a feedback loop of cost. To save water, you need more electricity for closed-system cooling. To get more electricity in a state that is rapidly phasing out coal, you need more solar and natural gas. Every resource in Arizona is now part of the factory's survival. But Taiwan has the experience. They have something that the US could take decades to build: a finely tuned human machine. Elite schools feed engineers straight into the factories. To fill the void, the company imported 1,000 veterans. By early 2026, they made up 40% of the Arizona workforce. But a plane ticket can't bridge a culture gap. The core of the problem is that you cannot simply hire a smart engineer and expect them to run a production line. In Taiwan, top graduates don't just learn the physics, they learn the machines. They are raised in a system where the fab is the center of the universe. In Arizona, the talent pool is distracted by competition. The brightest minds are being recruited by SpaceX, Google, or Tesla. They want to build things they can see. In a chip fab, you are working on things that are impossible to see with the naked eye. This is why replicating TSMC isn't just engineering, it's trying to recreate decades of culture and instinct overnight, and that comes with its own issues. Lawsuits followed. It was claimed the company favored Asian workers over locals. Unions attacked the use of foreign labor. These clashes drove up costs and stalled the timeline. In this desert, the chips will cost up to 30% more to produce than back in Taiwan. To fix the expertise gap, local colleges launched emergency programs. They offer 10-day crash courses to teach the basics of the factory floor. These efforts help, but the high cost of living and the brutal heat keep many away. Even with a $130,000 salary, people quit. But first, if you like these deep dives, make sure to subscribe. The American landscape is changing fast, and I'm here to cover it. This is the human vacuum of the desert experiment. By March 2026, the first factory found its rhythm, but the financial burden remains. Labor in the desert costs almost 2.5 times more than in Taiwan. Managers now take classes on how to talk to Americans, trying to blend strict rules with personal freedom. The gap is most visible in the maintenance culture. While the state is home to strong engineering programs at Arizona State University, the local talent pool has historically been geared toward aerospace. A career at TSMC isn't just a job, it's a high-stakes endurance test. Rebuilding this workforce is the hardest part of the Arizona transition, and the more you look at it, the harder it gets to call this independence. The factory can be built in a desert, the workforce cannot. To understand what America's really up against, you have to look at the original blueprint. Taiwan didn't build its chip empire by accident or brute force. It built its semiconductor culture over 50 years. The US is trying to compress that into 5. And real competition is nowhere to be seen. A semiconductor factory sits at the top of a fragile food chain that most of us never see. To keep a modern clean room running, you need more than just electricity and water. You need a constant, perfect stream of rare chemicals, specialized parts, and high-purity gases. The chemicals used are incredibly volatile. Most of them must be kept at exact temperatures and handled with extreme care. Labor and air freighting these materials adds a 20% premium to every chip made in Phoenix. Every chip carries a hidden tax before it even touches the factory floor. TSMC is surrounded by a dense local web of suppliers that has been growing for decades. It's a structural necessity. Without that ecosystem, even the best engineers and machines can't keep the chips flowing. To fight this, the US government is handing out billions in grants. A total of $39 billion is the overall allocation under the CHIPS Act for manufacturing incentives, part of which supports suppliers relocating to the desert. A giant factory can't survive alone. It needs a shadow economy to feed it. Right now, over 40 smaller Taiwanese supply companies are quietly setting up across Phoenix, creating more than 12,000 jobs in what's already being called Little Taipei to prop up TSMC. They are moving thousands of families across the Pacific Ocean, building the ecosystem in real time. Kids who grew up in Taipei now go to high school in the Arizona suburbs. They are taking out huge loans with soaring US interest rates, betting their whole family legacies that this desert experiment works. They pay top dollar for commercial real estate in Phoenix just to stay close to the mothership. If the Arizona project stalls, or if the government money takes too long to arrive, these shadow suppliers go bankrupt first. Building in Arizona means paying more for everything. Construction costs in the US are significantly higher than in Taiwan due to labor regulations and different safety standards. A gigafab in Taiwan can be built in roughly 2 years. In Arizona, permitting, environmental reviews, and construction tolerances stretch the timeline. This creates a terrifying gap. Even if the chips are made in Arizona, they are currently like brains without bodies. They have to go through advanced packaging, where it is cut, tested, and placed into a protective shell with connectors. For years, there was no way to do this in the United States. The finished silicon had to be put on a plane and flown back to Taiwan or Malaysia to be packaged. If a war or blockade hit the Pacific, the Arizona factories would be high-tech bricks. To fix this, a new packaging plant is being built nearby in Peoria. This is the missing link that could finally make the American chip industry independent. It will use a technology that means finished chips no longer have to fly back to Taiwan to be completed. By stacking memory directly on top of the logic processor, Peoria becomes the place where silicon transforms into weapons, smartphones, and everything in between. But the supply chain problem isn't just about chemicals and packaging, it's about the scarcity tax of resources. Across the valley from the TSMC site, Intel is spending over $30 billion to expand its own campus. These two giants are currently locked in a brutal war for the same limited pool of specialized contractors and materials. It's a turf war. There is only so much industrial-grade concrete in the American Southwest. There are only so many union electricians who know how to wire a pressurized clean room. When they need construction equipment, costs skyrocket. They are cannibalizing each other just to meet their deadlines. They both need the same high-purity helium and neon that is critical for chip making. During the 2021-2022 global shortage, prices for neon in the US spiked by over 600% as companies outbid each other just to keep fabs running. Scarcity is now part of the battlefield. This is exactly why the aggressive 2026 expansion is so dangerous. By pushing the plan to 8 to 12 factories and expanding the packaging plant to a $7 billion site nearby, the US is heavily increasing the strain on a system that already shows cracks. They're doubling down on a massive bet before the first hand is even fully played. The desert is running out of physical space. The power grid is groaning under the new load. Bidding wars bleed the smaller suppliers dry. But if the government subsidies run out before the local ecosystem is self-sustaining, the whole project could collapse under its own weight. The alternative is leaving 92% of the world's most advanced chip manufacturing on an island 100 miles, 560 kilometers from China. Arizona is a gamble, and the US is going all in. The chips, the weapons, the economy, they all ride on its success. But the desert it's built on doesn't care whether America wins. Thanks for joining me today. I hope you enjoyed the video, and if you want to see more videos like this, then please consider subscribing and turn on notifications. Really does make a difference. Thanks again, and I'll see you next time on Map Secret World.